So hello viewers and welcome back to another video on networking. So today we are going to have a look at the DNS protocol where we are going to just learn the basics of what is DNS, how it works, and what are the important terms that you should be familiar with while learning a DNS protocol. In later on videos we'll also see the packet formats and simulation in CPT and if possible in NS3. So without wasting much time, let's get started. So as usual, for any of the protocol that we learn on this channel, we'll follow the same content that is described over here. So we'll have an introduction why we need and how it works for the protocol that we are learning in first session, and then we'll follow for upcoming sessions with packet formats, simulation in CPT, and if possible simulation in NS3. So let's start the video with the introduction of DNS protocol. So just a few basic terms. So DNS full form means domain name systems. It acts as like a phone book or contact list in your mobile phone. So I'll clear this terminology, but just for now you can have an introduction and just keep this in mind. So while you want to call someone, you don't dial the phone number, instead you just search for the person's name. So that is the usual terminology for phone book or contact list that we use in our daily life. So let's say while you write the google.com, you don't write the IP address of Google server, and rest is taken care by DNS. So DNS is the protocol that helps you in translating your google.com with the particular IP address of it. So that means that is similar to how we go through our contact list and search for the person's name rather than searching for the person's phone number. And as human, we don't remember the phone numbers, we remember the person names. That's like similar to DNS. So that is the basic introduction, and that's all you need to know about DNS. So that is the whole work of DNS that you can do. That is the whole responsibility of DNS, to convert any name into IP address. And while we don't need to worry about what is the IP address for the google.com or let's say youtube.com or anything. Now there are a few reasons also, so that why we need this DNS. So let's uncover those reasons first. So here are those reasons. So first of all, that's human friendly, because instead of remembering the complex IP addresses, we can remember the simple names. So that's why the DNS is helpful. Then the core and essentials. So without DNS, anything on the internet doesn't work, because everywhere you go, everything is hosted on some servers that is not that can be anywhere in the world, and that is identified by unique public IP addresses, and we don't know or we can't remember those IP addresses. So that's why DNS is core and essential. Then flexibility and mobility. If websites changes and their hosting servers, the IP address changes but domain name doesn't. So that's like let's say for a person A, let's say you have a person A and that is having currently phone number something, let's say some 10-digit phone number according to Indian numbers, and then let's say after some time that phone number gets changed and then person notifies you. So you have to go through your contact list and manually change the phone number from that contact person's name. So that means the person name doesn't change in your contact list. The thing that is changing, that is the IP address over here, and in the contact list scenario, it is the phone number of the persons. So that's why it's flexibility and mobility. That is the reason why we need DNS. And the last is security. Right now with the DNS, there are so many things or so many security attacks or vulnerabilities that we can exploit. But there is something called DNS Sec, and this was the session that was recently given as a community talk on the APNIC. If you know this organization, you should be aware that they host open source or free to register what you can say talks, or you can say knowledge KT knowledge transfer sessions. So in that they have introduced recently they have recently took a session on DNS Sec, and that is like DNS with enhanced security. So that is also useful. So security is also needed, and that's why DNS is also, taking their hands dirty with the security. So it's like DNS sec load balancing of traffic, ability to avoid malicious interceptions can be implemented with DNS also. So that's why we need DNS to implement this kind of security features. So that is also one of the reason to have DNS. So now that you are aware about the basic understanding of what is DNS, why we need it, and everything is clear. So now let's brainstorm a scenario where we'll, in simple terms, just we'll understand where DNS works. So in this scenario, we have a browser running on your machine, and let's say this is DNS server hosted somewhere else, and this is videogeeks.in website hosted on some server that is not located in India. Let's say that is located somewhere in the world, right? And this is the, let's say, public IP address of videogeeks.in, right? And this is DNS server who keeps record of all the domain name with their IP addresses. So now if let's say your machine wants to get to videogeeks, how DNS works, let's first understand that in very basic terminologies. So first what you will do is on your browsers you will write videogeeks.in, right? Then as soon as you write, your machine will contact the DNS server that is configured by default. If you are connecting to your any Wi-Fi, home Wi-Fi or any organization Wi-Fi, the DHCP process that runs, that will fetch all the settings like IP address, gateway IP address, DNS IP address, everything will be fetched. And if you have not aware about what is DHCP process, we have already covered made a video on DHCP process, and that covers all the things like simulation, theoretical concepts, and brainstorming session, and everything. I'll have a link of that playlist over here. If you are not aware about DHCP, just go and watch that. So let's say you have a DNS IP in your machine. So second thing that your machine will do is to contact DNS server. It will say that what is the IP address of videogeeks.in, and in response the DNS server will reply with the IP address of videogeeks, and then your machine will contact videogeeks.in, and that's how it works. So this is how DHCP works. Sorry, not DHCP, this is how DNS works. But in reality, this is not that simple. Now let's deep dive into the process and let's see how it works in core. So this seems a simple process. This is actually simple explanation of DNS protocol. But let's see how DNS is structured in this internet and how it works. So now let's see how it works in the details. So here is your machine. Let's say here is your browser. Here is your VideoGeeks hosted server, and let's see the same scenario but with the detailed terminologies. So what works and what doesn't work, and let's say so the first thing in this scenario, let's say you go to your browsers and write videogeeks.in. You want to reach over here hosted server, and the first thing that your machine will do is to contact the stub resolver. So this is like a program that is running inside your machine, and this program will keep track of, this will be like table entries. The stub resolver will maintain the entries of it's like your local DNS. So it will have a domain name mapped with the IP addresses. So let's say first it will contact the stub resolver, and it will ask for the IP address of videogeeks.in. If you have recently been to videogeeks.in, the IP address will be there. I mean, like it might have been cached inside the stub resolver. So the first thing your machine will do is to contact your stub resolver. Now the stub resolver will check the for the IP address of videogeeks.in inside your RAM. Now if it is cached, it will be in L2 cache or L3 cache or L4 cache, whatever depending on your machine, or it will be inside your RAM. So stub resolver will try to get the IP address from the memory. Now worst case scenario, let's consider that you haven't been you have not recently been to videogeeks.in. That's why you don't have the IP address in the stub resolver. So memory will fetch that there is no record of IP address for videogeeks.in in the cache, and in reply your machine will try to contact the DNS server from your machine. So the first thing it does it did was to contact the stub resolver, that is like a local DNS. Now if it doesn't work, it will try to contact the DNS IP that is configured in your IP settings or provided to you by the DHCP protocol, right? So mostly you will have this Google's recursive DNS server, which is called 8.8.8.8, that this will be the DNS server mostly configured in your machine, right? And let's now see what will happen if you don't have your IP address in this stub resolver. So after that, your machine will connect with the DNS server, let's say Google's DNS server, which is called recursive DNS server. And this is called recursive DNS server because it will try to recursively try to fetch the IP address for the domain name that is there, that is you are querying for. Right now, let's say you're querying into Google's DNS server. Your request is going through internet to this Google's DNS server. Now it will also have something called cache. So let's say if someone else might have tried to visit the videogeeks.in server, then in that case Google might have cached the IP address of the videogeeks.in. So it will try to query if anyone else recently been to videogeeks.in, so that it will check into the cache and will try to find the IP address of videogeeks.in. In worst case, let's say there is no one who have been to videogeeks.in recently, and that's why you don't have the IP address in the cache. Now it will try to recursively fetch the queries. So there are so many other things, other DNS servers involved here, and how the recursive DNS lookup works. So let's understand that. So right now I have minimized all the things. Videogeeks.in is hosted here. This is Google's DNS server, which is recursive DNS, and we are querying for videogeeks.in, right? We tried to look into cache, but we haven't found anything. So we have something called the root level DNS servers, or that are also called as top level domain servers, or mostly that is like, if let's say your URL looks like this, videogeeks.in, it could instead of .in it could be anything like .com, .net, .in. So these are like top level domains. So these DNS servers, they are like boss of DNS servers, so that those stores the information for the other DNS servers that may contain this information about top level domain. So let's say in this case we have .in, that is top level domain. So Google's DNS server will try to find the addresses for the DNS server who manages .in, and in response this root DNS server will reply with the list of DNS servers, or you can also say TLD servers. Now we have something called TLD servers, which are like maintainers of particular top level domain. So let's say in this case we are fetching for .in. So Google will receive the list of TLDs, and it will try to query the first TLD, and it will basically ask who is managing videogeeks.in. Now in response to that, the TLD server will reply with the name address of the authoritative name server. So authoritative name server, which means the DNS server who manages the hosting of videogeeks.in. So that means this is the authoritative DNS server or name server, you can say, where videogeeks.in is hosted. So in response to this query, TLD server will reply with the address of this. Now in some cases your server might be managed by some third parties like Cloudflare or any other cloud service provider like GoDaddy or something like that. So in that case, the authoritative name server will be some another server, right? So after that, TLD queries completed, the Google's DNS server will finally try to make a call to this authoritative name server, let's say Cloudflare, and it will try to find the IP address for videogeeks.in, which this server, let's say Cloudflare server, will have zone file, and zone file here will have information about all the domains that can be hosted by videogeeks.in. Now you can see xyz.videogeeks.in. So this xyz is like subdomain. So zone file will have information about all the subdomains. Right now we are just querying for videogeeks.in, but you can note that we might have also something called abc.videogeeks.in, xyz.videogeeks.in. So those are called subdomains. So This will query for zone file, and zone file will have information about the IP address of this videogeeks.in. In response, the authoritative name server will reply with the proper IP address of the server where videogeeks.in is hosted, and then Google's DNS server will reply us back with the IP address of videogeeks.in. And before it replies, it also caches the response, so that in next queries, Google's DNS server will not have to go through this recursive lookups. And now your machine will contact the hosted VideoGeek server. So this is like happening, like proper working of DNS. And there are some core words that you might have got to know: recursive server or recursive DNS lookup, root servers, TRDL servers, authoritative name server, and stub resolver, and some other few terms. So please note this, and that's like proper working of DNS server. So in just simplified terms, this is the proper workflow of how DNS works in the core. So your machine will try to query for the IP address in the recursive DNS servers, then it will try to contact the root level servers, then TLD servers, then authoritative servers, and finally you will get the response and you will be able to reach to videogeeks.in. So this is like proper workflow. And these are few important terms that you should know, which is called root. So that is like top level of DNS hierarchy. TLDs, that is like top level domain, the level directly below the root, for example .com, .in, .edu, etc. Second level domain, that is like the main domain name registered by an organization or person or entity, which is like VideoGeeks, right? Or let's say cupofcoffee.com, or let's say some name.com, right? So those are like second level domain. Subdomains, so this is like extension of main domain used for organization. So something like abc.videogeeks.in or xyz.videogeeks.in. So that abc and xyz, that is referred as subdomain. Now recursive DNS. So when domains are used to map the IP addresses back to domain names, that is called reverse DNS. Now we also have something called recursive query. When DNS server fetches the complete answer on behalf of server, that is called recursive DNS. Something like Google's DNS server, which is that IP address of the Google's DNS server is 8.8.8.8. We also have something called iterative query. That means a query where server provides the best information it has. So in here, let's say TLD, those are like iterative. That means it is like static mapping of servers. It's like static mapping. It doesn't look up recursively for TLD servers, let's say for .com, for .net, anything else, right? So these are few important terms, and that's like basic overview of DNS protocol. So in next sessions, we'll start to look at the packet formats for DNS. But in today's video, I think that's it. If you have any questions about DNS and from whatever we explained today, you can just ping me in the comment section. And yep, that's it for today's video. We will meet in the next one. Till then, keep learning and keep exploring. So that's it. Bye bye.